All right, so today we're going to talk about Pythagorean Theorem. But with a pause and kind of draw this picture out and see what you and draw what you see. All right, hopefully you're back. You're drawing this picture. All right, so Pythagorean Theorem, and we have this triangle. So Pythagorean Theorem means we have a right triangle. That means we have a box, and we have the box means we have a right triangle. I mean a right angle. So it may not look like this, or may not be turned this way, but it's going to look something similar to this. All right. So in traditional Pythagorean theorem, we have a squared plus b squared equals c squared. So how do they get those letters? They take the angles that we see and they label the sides that are like across from them. Okay, so like this is side A, this is side B, this is side C, and many times they will um, label the sides according to what angle is across from them. Many times, not all the time, but many times. All right, so I'm going to do the same. All right, so A, B, and C, A, B, and C. These are my angles, and those letters, the smaller letters are my sides. All right, so now I'm going to look at it like our class actually does. So our class looks at this as adjacent, opposite, and hypotenuse. All right, and we're looking at it from a certain angle, and normally we're looking at it from angle A. And that's why I have that star here, angle A. So I want to look at the side that is adjacent to angle A, that's opposite angle A, and then a hypotenuse of angle A. All right. So the side that's adjacent angle A, opposite angle A, and then a hypotenuse. So this is angle A. For this picture, this side is adjacent of angle A. Let's look at this. Angle A, adjacent means it touches the actual angle. It's the side that touches the angle. All right. Opposite is the side that is opposite of my angle. So opposite of angle A would be this side. Our hypotenuse is always a slant and it's always across from our right angle. Okay, so we have adjacent squared plus opposite squared equals hypotenuse squared. Now the adjacent and the hypotenuse, they can be switched because their addition is commutative property, so we can actually switch those out. But the hypotenuse must be on the right side when we set it up. Okay, so adjacent is the opposite. I mean, adjacent and opposite, those can be switched out. So I can say, um, I can switch, well, if I were to switch this, or if I were to set this problem up, I can say that I want to put my opposite side first instead of my adjacent. I can do that if I'm switching this. So I can say opposite squared plus adjacent squared. I can do that for this problem. But my opposite must be on the other side. Um, oh, I think I put opposite. So it's hypotenuse. Sorry, it's a long day. There we go. Oh, that's almost not right. Hypotenuse. There we go. Switch that. Switch that. All right. So adjacent, opposite, hypotenuse. All right. So the hypotenuse has to be the slant. It's going to be on the side by itself. It's special. The adjacent and the opposite are going to touch the box. The hypotenuse never touches the box. It's across from the box. All right. So we're going to use this concept to answer some problems. All right, so let me set up a problem and we're going to look at how to solve it. All right, so let me set up a triangle. I'll switch it up. We'll do maybe one or two, maybe one or two. I'll label this. Make this a 12. We'll make this a 5. And we want to find the missing side. We want to find the missing side. Remember, we normally go off of angle A. So based on angle A, what is our missing side? So this is our angle. So let me label my sides. I can see my slant. There's my slant. It's going sideways. That's missing. So my hypotenuse is missing. That's what we're solving for. Maybe I should make that red because I can't see it. Let's make it red because I can't. Okay, so that's hypotenuse. All right, and then this has to be my adjacent because it's touching A. Touches A, so this is my adjacent. This is opposite or across from my A. So this is opposite. So we have adjacent squared plus opposite squared equals hypotenuse squared. I'm gonna plug in my numbers. So this is 12 squared, 5 squared, excuse me, 5 squared. It doesn't matter, but I want to keep it consistent. Doesn't matter, but I do want to keep it consistent for this video. So that's 5 squared plus 12 squared equals, I don't have anything for this, so I'm going to make this either hypotenuse squared or I'm going to make it an x. I'm going to make it an x. And this is 5 squared. This is not 5 times 2. This is 5 times 5. That's 25. 12 times 12, or 12 squared, so 144 equals x squared. I'm solving my equation now. So these are numbers. I can put these together. 25 plus 144. It's 169. To get rid of a square, I square root both sides. If you don't know how to do this, make sure you go back your notes, how to solve equations. Okay, so I'm going to mark this 2 and that square root. Those cancel each other out. So x is equal to the square root of 169. Now, if I can square root this to one number, then it is one number. If not, I leave it under square root. So square root 169. Oh, 13. So x is equal to 13, or hypotenuse is equal to 13. Okay, let's do one more. I know it's 10 minutes in. Let's do one more. Let's switch our triangle this way. Label this A, B, C. I want to say this is 1, and this is square root 37. Still working from angle A. So I'm going to label my sides angle A. I see my hypotenuse is my slant. So this is my hypotenuse. It's across from my C. There's my angle. What's touching my angle? My adjacent. So I don't have that one this time. So this is what I'm solving for. Across from my angle A is my opposite. So my A squared plus B squared equals C squared. Or for this course, we're going to use adjacent squared plus opposite squared equals hypotenuse squared. Again, I don't know what adjacent is. I'm going to put x squared. You can leave adjacent squared in there. I want to put a letter in there to make it easy. Opposite squared is 1 squared equals square root of 37, excuse me, squared. So on this side, I can't do anything with this. It's a letter and a number and an exponent. Can't do anything. 1 squared, or 1 times 1 is 1. This squared and square root, remember above, a square and square root cancel each other out, whether it's in the inside or out. They cancel each other out. So I actually just have 37. Now solve this equation. I still want to get x by itself because I have to get x squared by itself, so I can get x by itself. So these two have to be separated. These numbers need to be together. So this is going to be x squared plus 1 minus 1, 37 minus 1, or you can put the 1 underneath it. So this is x squared equals 36. So plus 1, I had a minus 1 and take it to the other side to balance it. This is, again, since it's not 2x, I have to take the square root to get rid of that 2, or that squared. So I'm going to square root. You don't have to do this step. I'm just showing you this so that you'll see that they cancel each other out just for this video, so that I can see now I have x by itself, which is the square root of 36. I leave it like this, but I do have to check it to see if it comes out to be one number. And it does. So my adjacent is 6.